Doing absolutely fine. Let's see. Why do I not know what I'm doing about half of the day, Aiken? I don't understand. All right, let me do this. Yo, 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 Aiken. Hello, hello, hello. How you been, my friend? I hope you're doing absolutely fantastic today. Hopefully things are going well with you, my friend. You know, this beard is gonna go soon. It's gonna go soon. I know. I know that the beard kind of grows. The beard grows evenly, but it does need to actually go soon. Um, Needs to have a full removal. It's getting to be that point, Aiken, where it's getting a bit itchy, and I'm like, when it starts to get to be a bit itchy, it needs to go and need to start over. Me and my beard have that kind of relationship. How was your day, Aiken? Hopefully it was good. Probably had a nice time playing F1 and everything like that. There you go. Hopefully, all right. All right. Got a little bit of a late start here today. Hopefully that won't be too bad. Okay, what are we doing today? Let's check here. Yeah, yeah. Got any plans this weekend? By the way, Aiken, don't forget about Ellis' stream on Sunday. Ellis is doing his charity stream on Sunday, so gonna have a lot of things planned, I'm sure. Hey Vince, were we supposed to do section 4.1 and 4.2 for homework, or just 4.1? Oh, that's a fair question to say. Probably if you're keeping track here, Vince, then 4.1 and 4.2 would be correct. Yeah, so 4.1 and 4.2, if we're keeping track here, would be the two sections that we had completed last time there, Vince. If you're keeping a pace with what we are doing. Hopefully that isn't too bad. Seems a bit tough. Well, take your time with it. That's fine. It's no big deal. Oh, I'm looking at the wrong section here. But we did go over finding line of best fit, correct? So at least I'm pretty sure we did. All right. I kind of figured we did. So I'm like, okay, I remember talking about that. I remember talking about residuals. I remember talking about certain things. I'm not crazy, Vince, just half insane. This is what you signed up for. This is what you signed up for, man. Don't worry, today will be Today, admittingly, will be hopefully a bit shorter. Hopefully a bit shorter, so. Last time was just kind of like we just kind of went all the way through. But today will be a little bit more more on the normal side in terms of pacing, so. Yeah, having trouble interpreting the slope for the residual and the percent median of the residuals. Yeah, so you just have to kind of get used to that. Like the slope for the slope for the residual is a little bit different. So. All right. Good morning, Jasmine. How we doing this morning? How we doing? I hope we're doing absolutely fantastic this fine morning. This absolutely great morning. Hopefully we're doing well. I'm doing well. I'm doing well. I'm gonna check one thing here. Oh, okay. Isn't the worst. Yay! Woohoo! All right. I like that. It's fabuloso. Fabulissimo. Babu indeed. All right. We're going to go ahead and wait here for just a few more minutes here, maybe a couple more minutes, and then we'll go ahead and get started. I got started with the stream here a little bit later than I wanted to, but just needed to prepare a little bit beforehand. So wait here for a few minutes, get everybody kind of trickling in, then we'll go ahead and get started here with the last couple of sections here. Hopefully we'll get this done here today. Probably will. Of Chapter 4. Okay, so Chapter 4. The last couple sections here. Sections 4, 3, and 4 for today. Everybody got plans for the weekend? I don't know. I got a lot of plans for this weekend, so plans for this weekend is going to be lots for me, so. More than I know what to do with, to be perfectly honest. All right. Let's take a good look here at this. Here. Got that. Okay. Yeah, okay, that's true. That. Why is that so far apart? Okay. This. Alright. Easy peasy lemon squeezy. Alright. Hopefully we'll get. Wait a couple more minutes, just a couple more minutes, and then we'll go ahead and get going here, ladies and gentlemen. We will go ahead and get going here in just a couple of minutes, and we will get started. And it'll be super chill, super easy time. Easy time, easy life. Pretty good today. This is what I needed. Hey, Alyssa. Did we learn least squares regression line? We did actually. That was the line of best fit, Alyssa. So But if you want to do another example, we can certainly do that today. That will go just definitely in line with what we did last time. So I don't mind doing another example of that. Remember, just really quick here for you, Alyssa. It's just a fancier way of saying least square regression line is line of best fit. So, hey Robbie, how we doing? But yeah, I'll be more than happy to show off another example in regards to that. And that shouldn't be too much of a problem whatsoever. Hey, my friend! Hey, Hilmir, how we doing? Long time no see. What have you been doing, my friend? I hope things have been well. Welcome, welcome. Hopefully things have been going well on your end, Hilmir. Hopefully. Things have been pretty chill. Just been enjoying the summer? Excellent. I've been absolutely fantastic. I get to teach, I get to have a little bit of fun, and I get to goof off probably like 75% of the time. All in all, I ain't gonna complain. Fan here. Yeah, tell you, I'll live a privileged life in that regard. Get to do what I love. Can't go wrong with that. I'm just lucky, I guess. I'm lucky. I'll just say that. I'm a lucky guy. I'm a lucky guy. I get to do what I love at the end of the day. And I love it. I'm lucky I get to share it with you guys. So, very lucky guy. All right. I think it's time for some intros. I think it's time to get started here. All right, let's do this, ladies and gentlemen. Okay, let's get started today. Welcome back to Thursday, end of the week time today, everybody. All right, so today we're gonna hopefully finish up chapter 4. Okay, we're gonna do sections 4, 3, and 4.4. All right, and that is going to be the goal here for today. But I was asked a question. Hey, amazing poet, how we doing? Hopefully we're doing wonderful. But I gotta ask a question here, right before class, before we start here, at least for me. Is having a little bit of issues with finding that line of best fit or least squares regression line. Let's go ahead and I do have this up here, so let me see here. So I know some of you are keeping with the space. I meant the pace of the homework. The space of the homework. Oh Lord, that's pretty bad. All right. So maybe you're having a bit of an issue here when it comes to something like that, which is perfectly fine. Sometimes it can be a bit confusing, which is okay. That's not a problem. So let's take a good look at it and let's see what exactly we're working with. All right. I think there was one exception to this rule. I just have to be careful. Okay. Oh, all right. Well, that wasn't too bad. Oh, okay. So I'm guessing here. Let's start. Oh, it's you, Granite. Oh, you're on your partner's phone. Oh, okay. Well, good to see you again, Granite. Good to see you. All right, Jasmine, that's fine. Was it, let me ask you this question here. All right, Alyssa and the Vince. Was it like a question like this? Was it this question right here? Like, well, if you don't say something, BCS, then, I won't. If you don't say something bad, that is. Was it like a question like this, Ay. All right. So Vince and Alyssa, is this the question you kind of had a little bit of tough time with? Like, this is question 2 here. Oh, well, it'd be helpful if I put it up on the screen. I think that would be helpful. Bruh indeed. My. All right, take a look at this question here. This is directly from the homework here. So let me at you here. Let me know if this is the type of question that you had a tough time with, and I'll explain this. All right. So let me explain. Yeah, that's fine. I figured it was this question. This is probably the question that people have a tough time with. So one of the things that we talked about here last time, and as friendly reminder, is we did talk about whether or not a particular data set had a linear relationship with a particular. Again, you took a look at the data set, and we said, does this have a linear relationship or not based on the correlation coefficient? Now we went through those steps here last time. Now to be on the safe side here, I'll show you how you kind of have to do this, because it does talk about kind of the interpretation behind the correlation coefficient. Okay. So, thanks, Granite. You too. You come back anytime, my man. You know you're always welcome here. All right. So, the way we want to do this here specifically is we're going to first do our steps here to see if there's a linear relationship. So we see that R here is negative 0.2344. So remember what we did here last time. We took the absolute value of negative 0.2334. Okay. And of course, we changed that to a positive number there. Again, that's 0.2334. And if you remember that appendix that we used here, no problem, Granite. Then remember on the second step here, we found the critical value associated with the sample size here that we're given in our table. Now let's take a look at our table here first and foremost. So we count, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 we have 10 points here in this data set. Okay, so 10 data items in the data set. So our n here is going to be 10. Okay. Oh, I'm so sorry. You're correct. Let's try it that way. All right. All right. No problem. All right. So what we're going to do next here is we're going to find the critical value. Now that's where this little guy is going to come into play. So let's click on that. And so if we have a sample size of 10, our critical value associated with the sample size of 10 is 0.632. Okay, so what does 0.632 mean? All right, so here's what it means. Essentially, we did our little comparison. We said, okay, and we said, remember we asked this question here, and hopefully this will serve as a reminder. So is 0.2334. Again, this has to be bigger than the critical value given to us in this table here. So let's answer this question here right away, guys. Is 0.2334 bigger than 0.632? Yes or no? Okay. I would suggest you get started with that right away, Rabia. Can't tell you to start or not. It's totally up to you. But we're 4 weeks in, so it's kind of on you to get that stuff done. Okay, so the answer is no. How did I get step 2? I got step 2 here because I looked at the sample size. So if you look at step 2 here, again, you just count how many points that we have here in the data set, which is 10. We have 10 points in the data set. And then we went ahead and looked at the chart here. And then so we saw that n is equal to 10. The critical value associated with 10 according to the table is 0.632. Okay. So we just referenced something here in this case. Okay, now because the answer is no here, let's talk about the importance here about what happens when the answer is no. Now because the answer is no, then there's no linear relationship here. Excuse me. Okay. Now you're probably wondering, what happens in this case if we do have no linear relationship? Well, that's going to help us out here solve this particular problem. It says, what would be the predicted stock return for a company whose CEO made 15 million? Now, in actuality, the answer to this question is, because there is no linear relationship, the answer to this question for any number that we put in here, the answer is going to be the mean of all the values in the data set. So that's essentially what we're going to do here, is that the answer, because there's no linear relationship, the answer will be the mean. And specifically, this will be the mean of the y's. Okay, so I do need to look at the table here in this case. So I look at the table here, and if I'm going to look at the mean of the y's, okay, if I'm going to look at the mean of the y's, I'm just going to add all those together. And I'm going to go ahead and get my final answer for this problem here. So I'm just going to take literally, but I'm going to take 6.38 and then add 30.26 and da 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 da, all those dudes. So let's go ahead and just keep adding. That includes negative 8.89, by the way. And then plus 4.24 plus 10.59 plus, what is this, 4.19 plus 11.27. And we will divide all that by 10 because there's 10 values. All right. Can anybody give me an answer here for this? Please add all these numbers up and divide by 10. So we got 17.3%. Okay. And I think they, let's go ahead and check here and see how many decimal places they want. Is it, Vince, is it exactly 17.3? I don't have it in front of me, so I'm just going to ask you. Oh, they do want one decimal place. Okay, if you rounded, that's fine, that's fine, that's fine. Okay. I'm sorry. They had 2 decimal places, and I'm like, okay, do they want 2 decimal places or 1? But I guess they just want 1 here. All right, so let's try it out. Oh, get that wrong here. Where are we? Give me a second. 17.3. Let me check now. Check that one more time. Did I get one of those? Oh, okay. You should have gotten 17.1. I think you got the wrong percentage there. It should be 17.1 is what I got. I think it's 17.131. Is that what you got there? Yeah, be careful about that. So I had to check it myself. I'm like, it's the correct way. It's just, yeah, that's the correct answer. So 17.1 would be the correct answer there. And then if it's like this one here, what's the predicted stock return for a company who's made 25 million? That too would be 17.1 as well, because again, there's no linear relationship between the data set due to R being too low. So in comparison to its critical value. So if we try that, then we get the right answer for that. So, any questions about that? hopefully that made that a bit easier to do now. Alright, so if I didn't expand on that last time, then apologies about that, but hopefully that will make a whole lot more sense now. Alright. Very good, very good. Okay. There's a third question on this part? What? Really? Hang on a sec. Explain what each point on these least squares regression line represents? You mean this one? As a quick... If you're talking about this question here, Vince, I don't know if this is the one. Doesn't, this is just like a multiple choice question, just talking about what the interpretation is. But you're just talking about predicted values here at the end of the day. Alright, well, I'll let you check that, and then I will, Alright, I'll let you check that and just ask me after class. It's fine, Vince. Don't worry about it. We got to move on to, like, the new material here. So I'm going to go ahead and answer that question after things are said and done here today. Alright, you'll need this here today. Alright. Okay. Alright, so today we're going to go ahead and start here with the last couple sections of Chapter 4. At least we did a little bit of review here for the last part there, so hopefully that gives you a friendly reminder about what we did last time here. Now we are going to go ahead and look at this same thing here again. If you remember what we did last time, at the end of the class last time, we did talk about residuals, okay? We did talk about using the line of best fit, if there indeed is a linear relationship, to say, okay, what would be the predicted outcome using that line of best fit as our model? Okay, and so we saw the residual, meaning what's the difference between our actual values that we observed and what would the model say if we use the line of best fit. And we saw, you know, they could underestimate, it could overestimate. It just depends on what our data set is and what numbers would work out. Again, this was contingent on the fact as if we had a linear relationship. Well, today what we're going to be doing is we're going to be looking at one more piece of data that also talks about the residuals and the line of best fit. And so let's go over each question here, and you'll see exactly where it kind of fits into play here. Talking about this last portion here, and we can extrapolate data here just a little bit more, talking about how not only how strong that relationship is, but quantifying it just a bit further. Okay, so let's take a look at question 1. We did talk about question 1 here last time. What are explanatory and response variables? We did discuss this last time here. Explanatory variables would be your x values. The response variables here would be your y values. Okay, so meaning to say you plug something in for x. All right, that's your explanatory variables. You get something back out for y. So once again, as I discussed here last time, it was like, hey, for example, the example I had in my last handout here was like caloric intake and body mass index. Okay, so more calories are taken, and then the response would be the body mass index after we take in those calories based on the foods that we eat. All right. Now, the main focus here of section 4.3 revolves around question number 2. Question number 2 asks, what is the coefficient of determination? So this is the new concept we're going to be talking about here. And so the coefficient of determination, based on the definition, says this explains how well the line of best fit works with the data set. Okay, so basically, i.e., how well the variation in the residuals is best explained by the line of best fit. All right, so essentially, if we want to get a good gauge, a percentage gauge in this case, an actual metric about how well the line of best fit would do in terms of predicting, be a good predictor for the data set in question, we can actually see that here by using the residuals in question that we discussed here last time. All right, and that's what this coefficient of determination actually means. Meaning the stronger the percentage is going to be, meaning it means that that line of best fit is a very reliable tool to actually use for values that could be possibly outside of that data set if it's strong enough, that is. Now, so what we want to do here is, what does coefficient determination mean? We measure the proportion of total variation in the response variable that is explained by the line of best fit. So again, just to reiterate here from question 2, we want to measure the proportion of total variation in the response variable that is explained by the line of best fit. Now here's the nicest part. Let's take a good look at the notation here. The notation here is r squared. So that's the notation that you see here. You're probably saying, r squared? That should look fairly familiar, that r squared. And it is. It is very, very familiar, because this r squared that you see here on the screen is basically your linear correlation coefficient that we found from before, that being r, and we just go ahead and square it. That's all we're doing. So if we know that there's a linear relationship between two variables, x and y, then, and if that happens to exist, we do the check and everything based on our sample size. And we can say, well, how strong is that? How strong will that line of best fit be with, with explaining the variability within that data set? Well, we can see exactly the type of percentage that we're dealing with. For example, as you can see here, if r squared was 0.9614, as just a random number I put down here, then you can interpret it just like this. So again, this is the exact wording it'll say. It says, how do you interpret the coefficient of determination? How would it be in words? It would say 96.14% of the variability in y is explained by the line of best fit. So, it could vary a little bit. The line of best fit, as we know, doesn't have to go through every single point, right? Remember, there is a little bit of variability. But if you have that little bit of variability, whether it be over or under that line, all right, it can be explained by the line of best fit here. And we could take the percentage of data items in the data set on average. And there we go. We got it. Pretty simple. So let's see how we can find this, though. Okay, just explaining it in words is all well and good. But we're going to need, of course, an example. And let's see how we can actually practically do it using our own two hands. All right, so in order for us to do that here, I'm going to go ahead and showcase this out here. All right, so let's do an example here. All right, so our example here is we're going to go ahead and showcase a problem here. All right, so I'm going to use this one here, and I'll write down the data set here on screen so you'll be able to follow along. All right, so this is talking about a geyser, so a geyser here. So they give us a data set here for a geyser like Old Faithful, okay, like in Yellowstone. All right, so we have the time between eruptions, we'll call it x, and then length here, which is y, length of the eruption. Okay, so I'll go ahead and put this down. Put this down as a data set for each. All right, so let's write this down. Okay, let's put this down here. All right, let's keep going. 11.70 and 1.2, 12.27, 3, and 11.60 and 1.77. 11.72 and 1.83. All right. Okay. So here is our time and the length here. All right, of this particular time between eruptions of a geyser, and then the length of the eruption. How much time in say minutes or seconds or whatever of the length of the eruption here, whatever the case may be. Okay, pretty simple and straightforward. Now, what we're going to do here is, of course, we need to set this up on our calculator once again. And again, hopefully from last time, I'm hoping from last time here that we have the settings already put together. So if you remember, we did the diagnostic on and stuff. So that should still, you don't have to do that again here, by the way. You don't have to do that again. So if you did that from yesterday, then you should be good to go, at least in terms of what we're going to be doing here on the calculator. All right, now for our case here, we're going to go ahead and let's take out the calculator here. Actually, before we do that, let's make sure everybody's on the same page. If you have your calculator in front of you, please type done in the chat, and we'll go ahead and get started once everybody has their calculator out. We got that done. All right. Make sure everybody's got that calculator out. Another seconds here. All right. Okay, so if you have your calculator out here, we're going to go ahead and hit the stat key here. All right, so we'll go ahead and get started here. We'll hit the stat key, and we'll go to edit. All right. Now, again, we probably have our couple of lists here from last time. This was the list that we just kind of randomly made up last time. We want to clear out those lists. Again, to clear out those lists, just hit that up arrow. Make sure that list is highlighted. Hit clear and enter, and it'll clear out your list here. So again, clear and enter. That'll be fine. All right, so we're going to go ahead and enter in all the numbers in the data set that you see here on the screen. List number 1 here will be for all the x's, and list number 2 here will be for all the y's. All right, did I skip a number? No, there are not only 9 of them. Oh yeah, there are only 9. Okay. I'm like, wait, there are 10? No, there's only 9. All right, that's fair. All right. 0.70, 2, 3, 7, 7. Okay. So make sure that it's here on the screen. All right. Once you guys have all your data items in your lists, please type done in the chat so that way I know who are at this step here. I usually give it a little time, so I know that entering in numbers takes a little time, which is fine. Making sure we got everybody's kind of got it on the same page here. Anybody having any issues? Any questions so far? Hopefully you guys are. If you have issues, just bring it up to my attention. I'll be happy to help. No, okay, okay. No, so we're good so far. All right, just making sure. Whew. Gotta be careful. Okay. All right, Victoria's done. Okay, good. All right, so let's move forward then. All right, so what we're gonna do next is we're gonna hit the second key and the mode key. Remember, we're just gonna quit back to the main screen. Again, we're just making double extra sure we're not entering in anything bad into the list, any bad numbers or whatever. So we're fine. All right, once you're back to the main screen here, let's go ahead and hit the stat key here once again. All right. We're going to go over to calc. All right. And if you remember here last time, we're going to go down here to number 4, which was linreg, again, linear regression, linreg ax plus b. Okay, so we're going to go to linreg ax plus b. Now, again, remember, if you have the old school calculator and all you see is linreg ax plus b at the very top of your screen, all right, so if you have the old school calculator, you'll need to enter in L1, comma L2, okay? If you have the submenu that looks like this should automatically default to L1 and L2. The X list should be L1, the Y list should be L2. Again, just to be on the safe side though, again, if you don't see anything in here or you have something different in both of these spots, if you want L1 to show up, you hit second and 1 for L1. Again, if you have L2, or again, if you have something different that's not L2, it's second and 2 for L2. Keep everything else blank, okay? You don't want these things entered in. Frequency list, leave alone. Store, leave alone. Just leave them alone. Not worth your time. Go ahead and hit calculate, and these are the numbers here that should appear. Are there any questions about that? Or actually, maybe I should ask, I apologize, maybe I should ask, did everybody get these numbers here? If you got these same numbers here, then please type done in the chat if you got these same exact numbers that you see here on the screen. Yeah, so Alexis, maybe what you chose is you may have chosen the wrong one here, which is fair. A and B could be flipped over if you chose this one. I'll show you what you probably accidentally did. Is if you hit the stat key here, you went to calc, you probably picked number 8 instead of number 4, and that would flip A and B there, Alexis. So you should pick number 4 instead, and then you'll get the answer for that. So I should be more specific here. Number 4, which is linreg ax plus b. All right, Sarah's got it. All right, Gia's got it. Okay. Okay, good. Okay, so all right, so we have these exact numbers here. Now, we saw this last time here. Now, you should have, again, A and B and R squared and R, okay? So you should have A, B, R squared, and R here, all right? Again, hopefully you see all these numbers here. We did this from last time when we set our diagnostics on here on the calculator, okay? So from what we did here last class, again, you should see R squared and R at the very bottom. Now, as you know here, A and B represent the slope and y-intercept of the line of best fit. So if we looked at the line of best fit here specifically, again, we do know this for a fact. This is pretty straightforward. Again, this would be 0.1854x and then minus 0.3779. Rounding. Remember, I'm just rounding to 4 decimal places, guys. So again, hence the reasoning behind that. All right. We take a look at their correlation coefficient here, which is R. That's going to be 0.9109. All right, and now we look at the correlation coefficient, which is right up above that R square, the coefficient of determination, excuse me, which is the square. Again, basically, all you have to do is take that 0.9109 and you square it, and then that's what you get for your coefficient of determination, which is 0.8298. All right. Okay. Now, once again here, let's talk about this for just a moment. So we found all these numbers here, but the one number we want to focus on here is the coefficient of determination, that being the R squared number. Okay, let's go back to what it says here for number 3. It says, okay, how do I interpret that number here, this 0.8298 in this particular example? That basically means 0.8298 is a percentage. That specific percentage is 82.98%. Wait, b is negative. Does that make it y equals ax plus b? Yeah, it still counts, right? You still have, I know it says minus, but again, it's the same thing here, Jasmine, as if I wrote it this way. I just took that extra step, but if it helps, you would take it this way. You could write it as 0.1854x plus negative 0.3779, right? I just took that added extra step of just making it minus straight up, but I'm still not doing anything different. I promise you that. Right? Now, that's fine. That's fine. That's a fair question. But yeah, I understand if signs change, you're like, you know, what happens there? But yeah, that's all I did. That's all I did. I swear. All right. So, here again, 0.8298 is reflective of a percentage. That means that 82.98% of the variability again, you just say it just like that, of the variability in y is explained by the line of best fit. But what it means is that, again, that's really, really good, okay? Meaning 82.98% of the residuals, again, the change in y here can be explained by the line of best fit. Again, the line of best fit doesn't fit every data item, but it fits most data items, and it's pretty reasonable. Okay, so that's a pretty good, means it's a good fit at, 82.98% of the time. It's a good predictive model, all right? So it'll be, and that's pretty decent, okay? Considering what we're working with here in a limited with a limited data set of only 9 values. So you could also think of it in layman's terms. Again, that model could be right 82.98% of the time. That's pretty decent in the world of statistics. Obviously, excuse me, you would like that to be higher, but you don't always have that option, again, because of the amount of variability in data items just within its own right. So, okay, any questions about that so far? All right. Hopefully that's pretty easy. Okay. All right, so let's look at number 4 here. Number 4 says, how do we determine if a linear model is appropriate? All right, so we did talk about this, about how we can find a linear relationship back in the last section. Again, how do we determine if a linear model is appropriate? It says a linear model is appropriate if a correlation coefficient R shows a moderate to strong relationship. Okay, so if we have a moderate to strong relationship, not a weak one, but a moderate to strong relationship between both variables, along with a good coefficient of determination. A good coefficient determination would be like 80, 90%-ish. It could be slightly a bit smaller at 70%, but again, if it has a good coefficient determination as well, that would show that a linear model is pretty appropriate between the two. So we do have two checks here. We did the check here that says, is a linear model appropriate using, say, the critical value and looking at R, and also looking at the percentage of, again, R squared here as well. A good way to check. Again, if they're both pretty reasonable, that means a linear model can probably be appropriate here for that particular study or data set, whatever the case may be. So you can even look at the scatter plot and kind of make a determination. But if you're not sure, just look at the hard data. It's definitely worth it along the way. All right. That's all well and good. Let's move on. Let's move on here. All righty. Now we're going to move on here into the last section of Chapter 4. Let's talk about the last section of Chapter 4. Yeah, that's all for Section 4.3 is just talking about the R squared there. So not too crazy. It's pretty much the same thing. All right. Now let's take a look here at the last section. And so let's talk about number 5. Now number 5 is something we're going to see quite often here in the textbook in terms of examples, and we want to be exposed to that here at this juncture. So we will see this in Chapter 5 a little bit, but more so along the lines of future chapters where we do see more examples using this concept. So number 5, what is a contingency table? So basically a contingency table is a table of data with rows and columns that are indicated with a category with totals of each written, again, each column and row. And this basically relates two categories together. So what does a contingency table look like in general? Take a good look here in the textbook, because it'll take me a while to write one out here. So, like, well, why don't I just show you here? All right. So take a look here at this page. Again, this is the start of 4.4, page 225. This is where you want to find it. This is a contingency table here. Again, this talks about, in this case, this particular table relates the level of education and the employment status. So, okay, you survey a whole bunch of people and you say, well, tell me what the highest level of education you've completed and tell me your employment status. So, are you employed? Are you unemployed? Or are you just not in the labor force? Maybe you're a house husband, housewife, maybe that sort of thing, disabled, whatever the case may be. Hey, Beast, how we doing? Beast howdy, my dude. All right. So as you can see here, you can see like a bunch of people fall underneath those categories here. You could be maybe say you didn't finish high school, but you're employed. So, okay, that's fine. Or you're a high school graduate and, nah, don't worry about it, my friend. It's all good. All is forgiven, trust me. You're a high school graduate and you're unemployed. Okay, so then, you could fall underneath that category. Whatever the category you fall underneath, but you're relating those two items together. So we're going to see a lot of these different types of contingency tables in different examples. Now, the real question is, what do we want to get out of these contingency tables? What's going to be, pretty important for us to get out of these types of contingency tables here using the rows and columns appropriately? Let's talk about the next part here. All right, so number 6, what is the marginal distribution of a variable? So we're going to talk about marginal distribution here. So marginal distribution talks about and says it's the frequency or relative frequency distribution of either the row or column of the contingency table. So let's say, for example here, let's go back to our example here in the textbook. Textbook here actually surprisingly does a pretty good job. So looking at the definition here, we want the frequency or relative frequency of either the row or column of the contingency table. So in this case here, the easiest way to determine that is if we look at the rows here and we just add up the amount of people in the row that we surveyed. So we add up in this case here, based on what you see, that'll be the 10,179, the 33,624, the 35,407, and the 49,534, and we put that total out here on the right. Or we can add in the column here. We can add, say, the 10,179, 945, 13,271. We can add that up together here and put that total here on the bottom. That's what that marginal distribution means. And so we get a clear picture here. Let's go to the next page. Just like so. So this table here, as you can see here on the screen, would be a perfect example of a marginal distribution here. Again, in this case, we added up the frequencies of all the rows and all the columns together. And at the end of the day, you should have the same amount regardless. Again, in this case, this survey asked 208,000 people for their, for their opinion, or not their opinion, for their status. All right, so you could also do this here with relative frequency distribution. So that works pretty much the same way as you can see here. Let's look at the next page. So this one here is pretty easy because you just add up the rows and columns. If you're doing relative frequency distribution, well, let's take a look at what that looks like. That looks like something like this, like you see here on the screen right now. All right. So again, what do? You do the same exact thing here. You add up the rows and columns, the appropriate totals, but you take it out of the total amount of people that you actually asked, which in our case was 208,720. You're probably wondering where they got that number from. Go back for just a moment here. They got that number right here. So this last number that says 208,720, the total amount of people, okay, overall for the entirety of the table. So, and then that helps with the relative frequency distribution if you're trying to put that together. And as you can see here, what you should get in a relative frequency distribution, when we first talked about it, you should get 100% at the end of the day, hence why we have a 1 here at this very bottom right-hand corner. All right. We'll look at an example ourselves here, but I just want to at least showcase it here on, you can see here at least how it works early on. Any questions about that so far? Okay. Okay. Let's look at the next question here on the handout, and then we may look at an example here as well. Let's talk about number 7. Number 7 says, what is a conditional distribution? All right. So a conditional distribution is a relative frequency distribution based on the response variable, i.e. every column. Okay, so every column will be kind of like response variable, we said, is going to be our y variables. Now our y variables here in a contingency table are essentially every column here. So again, only for every column here. All right. So again, the important categories that we use are going to be the ones up top. All right. So that's going to be the important ones here, at least in this case. All right. So the question is, what does that look like here on a contingency table? All right, so what does that look like on a contingency table here? So let's go over to the next page here. This is what we got here, Jasmine. So I gotta move forward here because I gotta do the next example here. Actually, right. No. Okay, cool. So let's take a good look here at the conditional distribution. That's not what I want. There. All right. Here we go. This table here that you can see on screen is a conditional distribution. All right, this is on page 229. And notice that this conditional distribution is looking at each column individually. Now, the way it works is it's fairly simple. All we have to do is take the amount that we have here in each particular column and then divide it by the total of that column. So the total of this column here was 24,395. Now again, you're probably wondering, saying, where do you get this 24,395 from? Let me go back a couple pages here for just example. This 24,395 was the total from this column here. If you add the 10,179, 945, and 13,271, you get a total of 24,395. So how many people fall underneath this category, did not finish high school, and are employed? Again, there are 24,395 people who didn't finish high school. How many of them are employed? Well, here we go, 10,179 out of 24,395. So again, in this case here, 0.417 or 41.7%. And you can continue going down the line here. Notice that if you add up the percentages together, they should all equal 1 or 100% at the end of the day. So we're not adding rows, we're not adding columns together. We're not adding rows, okay? There's no rows involved for this. It's just adding up each relative frequency for each column specifically. So that is the notable difference here between a conditional distribution and what we did here before, where we took each of the rows and columns into account. Okay? So where we took the totals in those instead of looking at it individually for each. Right. By the way, again, the row does not have to equal 1 because we're not looking at it from that perspective. We're just looking at it for each column in that perspective. That's why we get that in that instance. So let's take a good look here at an example. I think an example is in order. Done a lot of talking here, but an example certainly is very relevant. Get to that example here. There it is. Okay. So let's take a look here. And we can see how this works out. It's very simple. So let's take a look at number 7. All right. Now that shouldn't be a problem. I'm almost, I actually am almost done. But yeah, actually I do have a couple things I need to talk about. How about we do that? How about we do that right now? How about we take a 5-minute break right now? Does that sound okay? I don't have much to go. I don't have a very long to go, but I do have several things I need to talk about after we're done here. So let's do that right now, folks. Let's take a 5-minute break. We'll come back at 12:05. All right, so I'm going to stop. I know this is an odd place to stop, but that's okay. We'll come back at 12:05, and then we will resume starting with this example here, which is number 7 on page 234. Okay? We'll come back at 12:05. Let's do it. All right. Like I said, I always listen to you guys, and I didn't give you a break last time. That's fine. That's fine. Trust me, I'm not upset as long as it helps. We're all human here, folks. We'll be right back here at 12:05. I'll put that splash screen up, and there we go. We'll be back. Yes, for a posture check there, Techno. Absolutely, my friend. Thanks for redeeming the points there. I appreciate that. I hope you're doing well. Alright, there we go. About ready to get started here. Alright, everybody back? I hope so. Everybody, everybody back? Yes? Bueno? What's a not... What's a not-so-normal go-to snack for me? Ooh. Let's see. Not-so-normal go-to snack. Now, I have regular snacks, mind you. I just had, like, bite-sized Oreo things or, like, Chex Mix. But maybe a not-so-normal go-to snack at times would be, let's see, shrimp, what's that called again? Like shrimp rice cakes. That's what I would say. Shrimp rice cakes. Shrimp rice cakes. That's what I think would be a not so normal go-to snack. I think those taste pretty good. Those taste pretty good. I ain't gonna lie. I can't go wrong with that. Shrimp flavored rice cakes. Yeah, so eating avocados with lemon and that does sound good. Would you be eating it straight, or would you be eating it with like a chips or something like that? I don't know. Some people eat like for example, I could have mustard and mayonnaise with fries, and that would be fine. Do I have office hours after class? I'm just missing. Yeah, of course I have office hours after class, Sarah. Of course. Be more than happy to take on your question. All right. Okay. Wait, how is that a swear? What? I don't know how that's a swear. What is not a swear? um. Yeah, put some lemon juice on it. Yeah, ooh, so good, straight up. I respect that. All right, let's continue moving forward then. Man, I'm getting hungry now. My favorite beverage. My favorite. Max, my dude, how you been? I hope you're doing well, my dude. I hope streaming is going absolutely fantastic for you. What's my favorite beverage? My favorite beverage is I love me my green tea. Mind you, I love me my green tea. So I have a lot of favorite beverages, but it has to be of all the favorite beverages. All the favorite beverages. Okay. It has to be milk tea. Milk tea is by my far my favorite beverage. I don't know what it is, but milk tea is just that good. Just that good. Do I have office hours on Discord? Yes. Yes, I do, Sarah. So we can contact you. If we have Discord here, I got that. Max, you got a new maths teacher? Yes. All right. All right. I like that. I like that a lot, Max. So now you have a new maths teacher. It's not as bad as the last one, right? Are you feeling good about this one? Feel good about this maths teacher, Max? I have to ask. Hopefully it'll be better. All right. So, while Max is coming out with a response to me, Let's go ahead and take a look here at number 7. The one with teaching me set 1 to set 4. Ooh, there you go. Well, you know, change of environment, change of pace, my friend Max, is certainly better. But as always, Max, I always extend out the offer to you, and I will always be willing to help you out if you just ask. You want to ask me on Discord? If I'm on Discord, please feel free to ask Max anytime, okay? No charge, no nothing, no money involved. Just, hey, let's just help each other out, yeah? All right, so let's look at number 7 here. All right, let's look at, let's go ahead and read off number 7. Let's see what we're looking for here. All right. Number 7, Made in America. In a recent Harris poll, a random sample of adult Americans 18 years or older was asked. When you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? The results of the survey by age group are presented in the contingency table below. So here we got all the age groups, 18 to 34, 35 to 44, 45 to 54, 55 plus. Okay, so here what you can see. Yeah, the structure's very good. He done 2 months more. He did 2 months. He done 2 months of standard form and then okay, that's good. I'm happy to hear that. Very, very happy about that. All right. So let's take a good look here at the contingency table. Now, as you can see here, it's already on the screen. You see that it's again a marginal distribution. Again, you've added up all the rows and columns here. Now, what we want to be doing here is we're going to do a relative frequency marginal distribution, and then we'll also do the other type here, which is a contingency distribution. So, no, I'm sorry, conditional distribution. Apologies. All right, so let's go ahead and do that right now. We'll go ahead and do a split screen here. I need a little bit more space, obviously, in order to do that. Let's do that right here. He says it like we're stupid. Well, okay. At least it's easy to understand, though. You know, maybe. At least it's easy to understand, though. Talking down to people is not good either. So, hopefully it doesn't talk down to you like your little kids. That doesn't sound very nice. All right, so let's do letter B here. I'm going to do letter B. Let's do a relative frequency marginal distribution. Okay, so that's what we're going to do here first. So let's go with more likely. I'm just going to make some tables here. More likely. Less. I'm going to just paraphrase here. Less. Neither. All right, we got 18 to 34. We got 35 to 44. Okay, that's good. I know we don't call you stupid, but you know, when you're like sounding like you're patronizing, you know, it's just like a different story. I don't like to talk to people like that. We're all adults here as far as I'm concerned. Unless you want to act something different. That's okay. Anyway, let's take a good look here at more likely and less likely and neither. Now, the way we're going to do this here is we have all the numbers already set up and ready to go. All right, so here, again, if we're doing a marginal distribution here, we're going to take the total here, in this case, 1329. All right, so actually, I'm going to put this, what I do need is, actually, I'm going to put this on the left. I'm going to put this here on the left because I do need a little bit more space here, so go ahead and do that. All right. So notice we have 1,329 that are more likely out of the total of 2,160. So that's what I'm going to put over here to the right. I'm going to have 1,329 over 2,160. And really quick here, can anybody tell me what the decimal equivalent is going to be? Give me 4 decimal places, guys. So 1,329 divided by 2,160. can I get a decimal equivalent here out the 4 decimal places? Can anybody tell me what that is? We've been doing like 2 pages of work per lesson. Ooh. I gotta ask, is that pretty fast, or is that just the right pace for you? Anybody got an answer for me here? Your own pace? Oh, good. If it's your own pace, then that's fine. 0.6153. All right. Very good, Vince. All right. Excelente. All right. Okay. Okay. Jasmine, hopefully the next one it'll be there. Max, have yourself a great one, and feel free to talk if you like some help at Max anytime. Okay. All right. So here we got 66. Next one here we have 66 or less likely. That's going to be 66 out of 2160. All right. Let's get a decimal equivalent for that. 66 divided by 2160. What do we got for that? You give me a decimal equivalent for that. 0.0306. All right, very good. All right. Okay. All right, good. All right, got that. Nice. All right, now the last one here is going to be 765. Again, that's the total for the neither row. So 765 over 2160. And we're going to go ahead and put that together. And what do we get for that? .3542. All right, good. All right. So that's going to be our answers here. Again, if you add these up, they'll approximately equal to 1 here. The 2160 is the total here, Rabia. So again, if you see here, 2160 is the total amount of people that we asked here in the data set on this contingency table. As you can see here, that's highlighted. All right, so that's why I chose the 2160 here, since we're taking the total of how many people we asked overall. All right, cool. Now let's look at each column here. Let's look at each column. Now, can you tell me here, let's look, now that you have a good idea about how this works. We took each row, now we're looking at each column. How should we do the 18 to 34 column if we're doing a relative frequency marginal distribution? How should I compute it out here underneath the 18 to 34 column based on what you see here on the table to the right? How should I solve for that there? How do I get this 18 to 34 column, guys? How do I get that relative? How do I get that relative frequency there? You guys tell me. I can wait, guys. It's not a problem. 238 over 542. That's a good guess. Not quite though. Take a look at what I did here for the rows here. Remember, I divided each one by 2160, didn't I? Didn't I do that here? Remember, I'm just doing relative frequency distribution. We'll be doing that part there, Gia, then part of the next question. So you got the right idea there. It's just not for this question just yet. 542 over 2160. That is correct. Yes. All right. That's correct. So there are 542 people in the 18 to 34 category out of the 2160 people that we asked. What's that as a decimal? What's that as a decimal? So we're trying to find out relative frequency here, Rabia. 0.2509. Okay. So I'm taking up the total here. Take a look. Isn't this the total here? 542. So the number of people in the 18 to 34 category is 542 out of the total here, which is 2,160. And then basically that's how we go ahead and do that. 542 divided by 2160. How about, let's do the next one here. Let's do the next one. How about 35 to 44? What would we do there? You guys help me out with this. Me talking forever is kind of tough. How would we have that here? All right, how do we get that, Alyssa? I would agree with you, but how do we get that really quick? Okay, good. That's correct, Alex. All right, so both correct here. 536 over 2160. Again, there's 536 people in that column out of 2160, or the 2160 looks pretty bad. All right, out of 2160, which will give us a grand total of 0.2481. Good. All right, good stuff. 45 to 54. I think you can guess what's going to happen next. This isn't going to be overtly too hard. I know that my table. Look, guys, I know my tables are pretty bad, so just go with me. All right. All right. So the next one here is 546 over 2160. Anybody got a decimal here for me? Got 546 over 2160. 2528. Okay, 2528. We'll roll with that. All right, and then this last one here for 55 plus is going to be 536 over 2160. Just don't have space to put that in because I'm not smart. And that's going to be the same thing here, 0.2481. That I got from the second column because it's the same number. So, all right. And so that's how we come up with, again, our relative frequency marginal distribution. Okay, so that's our relative frequency marginal distribution. All right, any questions about that before we move forward? Any questions? Otherwise, I'll move forward. Got one more example to do. Yeah, so this is relative, again, just understand this is relative frequency. Marginal distribution. That's what this is, Alyssa. So this is not conditional distribution. We haven't done that yet. This is marginal frequency, relative frequency marginal distribution. Okay. What is the more, less, or neither for? in this case here, that's just part of the what they asked in the survey here. If you read the question up here, it says, when you see an ad emphasizing made in America, are you more likely, less likely, or you're neither more or less likely to buy it? You can just read that question there, Jasmine. Number 7 on page 234. All right. Any other questions before I move forward? Any other questions? Nope. All right. We're going to move forward here. All right. So last part here is we're going to do a conditional distribution. All right. So let's do a conditional distribution here. That's going to be basically part D. So I'm just going to go ahead and paraphrase the table here once again. We have more, we have less, we have neither. Okay. We have, again, our age groups here, 18 to 34, 35 to 44, 45 to 54, and 55 plus. Okay. Now, in this case here, if we're doing a conditional distribution, let me show you how this works, and it's not too hard. But if we're doing a conditional distribution here, the conditional distribution basically works like this. Instead, it's kind of like what Gia had said before here. We're now looking at the totals of each column, and now we're looking at what is in each particular part of the column. So again, if we say how many people total were in the 18 to 34 column, well, there's a total of 542 in the 18 to 34 column. Okay, there's 542 people that were between 18 and 34 that took part in this survey. How many of them are more likely? In this case, 238 out of the 542 18 to 34-year-olds that we surveyed said that they were more likely. So, in a conditional distribution, that's exactly what we want to reflect. So we want to say 238 over 542. And then we figure out what the decimal equivalent is going to be here in each individual part. We're going to have a lot of different decimals here for sure, but essentially that's what we're going to be doing here. So again, for less, we'd have 22 people in the 18 to 34 column said less out of the 542 total that we surveyed. Okay, or again, for neither, we had 282 people out of 542. So we're going to find decimal equivalents for each, of course. I'll go ahead and do this one here, straight up. So 0.4391. Ah. 0.0406. And then finally this last one here, 282 over 542. 0.520. Okay. And this is basically the conditional distribution for the 18 to 34 category, just as part of our example here. Again, if you add these up together, this should be like 100%, okay, or 1, or again, around 1, because we do round to 4 decimal places here. Of course, it's around 1, okay? So it either is exactly 1 or very close to 1. All right, so now that we have that, let's take a look at 35 to 44. What would we have here for more? What should I have here then for 35 to 44? You take a look at our table here, 35 to 44. 536. 536 is what we have total there, Vince. But what am I going to divide here for the more category? 0.6138. How did we get that? How do we get 0.6138? $329 over 536. Okay, very good. Very good. All right, that's good. Just trying to find space here, guys. Sorry. So you got 0.6138. Okay. All right. Good. What about less? What about less? All right. That looks good here, Rabia. Very good. 6 over 536. That's correct. Which is 0.0112. Let me check if it's 111 or 1112. Remember, you do have to round appropriately here. So, can't forget about that. Oh, 6 over 536. 0.1112. Yes, that's correct. 011. Yeah, don't forget to round there, Robbie. It's important. All right, how about that last one there? Underneath the neither category. What's that last one going to be there? 210.375? Okay. 210. Uh-oh. I think you got the wrong number there. Careful. Should have 201 over 536. Okay. It's still 0.375 though. All right. I was a little worried that you got the wrong decimal because it was the wrong thing. All right. But no, it's actually still 0.375. Okay, good. All right, good. And all you have to do after that, of course, is to rinse and repeat with the other two categories just appropriately here. All right. So again, it's not too hard to kind of figure out what you need to do. Again, you can add this up here. It'll be hovering around 1, very close to 1, or exactly 1. And again, you could guess what's going to happen here again. I can paraphrase here just a little bit. I'm not going to go through each one here, but we get 360 over 546. We get 22 over 546. Again, I'll leave it to you to figure out what these decimals are. 164 over 546 is what we get here. Figure out what that decimal is. And then 55 plus here would be 402. 402, thank you for the posture check. 402 over 536. And we have 16 over 536. And we got here 118 over 536. All right. Again, notice I'm just doing these for the columns. I'm not doing these for the rows whatsoever. Okay, so again, we would then find the decimal equivalents for each of these fractions here. You put them together like you do the first two columns you see here. And there you go. You have your conditional distribution. All right, and that's all you got to essentially do for that. All right, any questions about that? Thank you for the follow. Appreciate it. No? Okay. All right. So, that effectively, ladies and gentlemen, is going to be the end of Chapter 4. Okay, so that effectively is the end of Chapter 4. All right? that's the last example here for chapter 4 that we're going to do here. I do have one more question to go over, but that last question is kind of a throwaway question, but again, it can occur here. So again, let me go over question 8 here, which is the last question here. It says, what is Simpson's paradox? Simpson's paradox can happen in statistics is when you have a situation where two variables have an association with each other, and it dissolves or goes away with the introduction of a third or new variable. So I don't think any of it is super hard to find the answers. No, just knowing which concept to apply. Yeah, exactly. That's a definite good way of putting it, Jasmine. That's how I try and do it for you. It's just like, it's not really super hard. It's just knowing that process about how to find it. Yeah, that's why I try and point out the process here as easy as possible. So sometimes what can happen in stats is we could have two variables that are very closely associated with each other, such as the employment and your your furthest level of education. But sometimes a third variable could break that relationship for whatever reason, between both of those. So, for example, here, those numbers could be skewed if you introduce a third new variable of I don't know, economic crisis or whatever. All right. It could be something akin to that. All right. So, again, an economic crisis would skew that data in some certain direction. And then essentially, that's what you'd end up with at the end of the day. You'd end up with different data that would probably reflect that the economic crisis, and you'd have less jobs and more people be unemployed, and of course you'd have skewed data. And that can happen, but it doesn't happen all the time, but it can. All right. So you always try and make sure that you have a pretty solid relationship, but understand that sometimes that can occur. Now, having said that, and having all the chapter 4 stuff done, all right, what I do need to tell you is that the test and the homework for chapters 1 through 4. Let's talk about that here. So the homework and test for chapters 1 through 4. It should definitely allow you to join. I don't think I've had a problem with that. Hang on a second, Sarah. Give me a second. I will. I'll give you the link here one more time. Then, but just give me a second here. I just do need to make this announcement. So the homework and test here for chapters 1 to 4 will be due on this day here. It will be due on the 30th. Okay, so that's 2 weeks from today. So the 30th here, it'll be 2 weeks from today when the homework and the tests will be due. Now, I do need to get into a little bit of detail here in regards to the test, so that way it'll be a little bit more clear for you exactly what's going on. So the homework you guys are pretty comfortable with. Let's talk about the test here in a little bit more detail. Now the test here specifically has a couple of options. Okay, you have 600 minutes to finish the test. You have 10 hours to finish the test. You have 5 attempts on the test. Again, as I said earlier at the beginning of the semester, you have a practice test. That practice test is essentially the real test, just with the options of help me solve this and show me an example. So the practice test is, pretty much the same questions, just with different numbers. All you have to do is, again, you practice with it, and you will not have the show me example help me solve this for the actual test, so be sure not to rely on those. Don't use those as a crutch to get you through the problems. You have to be able to understand each problem and how to do each problem in order to do well for this exam. All right, but you do get 5 attempts and 10 hours of which to finish. Now, I also put an option in there, which is what's called a save for later option. Let me describe what that means. So let me go to the big screen here for a moment. All right. So what does the save for later option mean? The save for later option means is let's say you start out a test and say, I think the test is like 30 questions or whatever. But let's say you start off the test and you do the first 5 questions. Okay, you're going to do them in order. Okay, you will do them in order, but you do the first 5 questions. And, let's say you get a little tired. You're like, I'm pretty tired. I'm kind of mathed out. Or, again, you're just tired because it's super late at night. Whatever the case may be. You can hit the button that says save for later, and you can essentially log off, and you can go to bed. All right, so you go to bed, or log off for whatever reason happens, and you can come back the next day and you can restart the test where you left off. So since you finished the first 5 questions, you'll start off at question number 6. Again, the caveat is for the save for later option is you cannot do the first 5 questions, okay? So you cannot redo any questions that you did from before. But you can stop and you can like take a break or again log off, do whatever you need to do, and then restart where you picked up where you left off last time, and then proceed to do the rest of the test from there. So there is a save for later option for you guys just in case if you do need to do that. Again, you don't have to do it all in one sitting all at the same time. So that way you can take it at a pace that you're comfortable with and not have to feel like super duper overwhelmed. So hopefully that reduces at least the amount of anxiety in terms of taking the test there, and it should be pretty easy to take care of. Now, one more thing I will say here. Let me point this out. The full disclaimer time, everybody. Full disclaimer time. I am giving you 2 weeks from today to finish this test. Okay? Again, normally I would give a week's worth of warning, but I'm giving you 2 weeks. All right? 2 weeks of which to finish this exam. So, what I am going to say here is, and what I'm going to say right now is this. Do not ask me for any extensions. I've given you plenty of time of which to finish. Literally since the beginning of the semester, it's been there. It's been waiting for you. You've been able to take it at your own pace. I've been giving you every option of which to say, but don't ask for any extensions. I will not give any. This is what you get. So if you're keeping a pace, that's good. If you're falling a little bit behind, that's fine. You still got 2 weeks of which to finish that homework and tests. Make sure you get that done within the next couple of weeks, okay? So I've given you plenty of time here of which to get on that and get that squared away and get it sorted. All right? Are there any questions about that so far? Any questions? Are we going to have a class review before the test? And the answer to that, Rabia, is no. We're not going to have a class review here because the practice test is effectively going to be the review. If you have questions, though, you can certainly ask me during office hours. I don't got a problem with that at all. So, I don't got a problem with that at all. That's not a big deal. All right. Well, yeah, of course we're gonna have classes, Jasmine. Jasmine, just because we're doing a test doesn't mean everything stops. It just means we keep going. So we're gonna be doing new sections and new material. So this doesn't mean that class stops. It means that the test and homework is due on that day. But we're gonna be moving on to chapter 5 here for next week anyway. If you want it to stop, you can, but that's not how it works in real life. Real life, it ain't gonna stop. Time's gonna keep moving, regardless of what I say. Sarah, there's the link there for Discord. You just have to click on that, and then you should be invited. You should be able to get in. I can check my Discord. Check. Oh, not my. All right. Oh, there. I see you. I see you, Sarah. I see you in there. All right. I'll show you my Discord stuff. Not a big deal. Well, this is the time, Rabia. You gotta put up. You gotta make sure you do the work. Like I said from the first day, I ain't gonna make you do anything. All right. At the end of the day, you're all adults and you're all accountable for your actions. So, again, you guys do you, and I will certainly get that squared away. Oh, you got it? Perfect. Okay, no problem. All right. Does anybody else have any questions about the test and whatnot? Don't worry, Robbie. We'll have a little bit more fun. Okay, we're going to be doing probability in the next chapter, so that's going to be what's going to be there moving forward. If you guys want to talk to me via Discord here, you can click on General. And if you click on general, then you can type in stuff here. Yeah, like Sarah, you're typing in stuff here, so that's good. All right. Any more questions over the exam or anything of that nature? Again, just want to be able to clear up any questions that you guys might have before we head out for the weekend. Office hours has always been the same every day for the whole semester. Again, 1 o'clock to 4 o'clock here on Discord. So right after this class, pretty much. So right after I'm done streaming here, Vince, I have office hours from 1 to 4. Okay. You'll communicate via Discord? Okay. All right. All right, everybody. Excuse me. All right. I want to thank everybody here for coming out on here to stream once again. All of you are absolutely fantastic. All right. I will be sending out a reminder email about when things are due and whatnot. So you will see an email. I will send that out to the whole class again. For those people who don't watch the live streams, that's fine. All right. And so we'll talk about that, and we will go ahead and move forward. All right. Chapter 5 here for next time. But again, if you do have questions here over again chapters 1 through 4, you guys know exactly where to find me. I'll be more than happy to answer and address any questions that you may have. All right. Everyone, have an absolutely wonderful weekend. For those of you coming on Discord, I see you guys. I will be right there. I'll be right there in just a moment, right after I'm done with the stream. But thank you again very much here, everybody. All of you are absolutely lovely people. I love you all. I love you all. You guys are absolutely fantastic. You guys best make this class fun and exciting. You guys are awesome. All right. Take care, everybody. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. Have a great one, everyone. We'll see you next week, if not on Discord beforehand. And yeah, good luck on the homework and test there. All right, take care, everybody. We'll see you later. Have a great one, everyone. Take care. Bye. Bye, everybody.